All right, this video is a continuation of the last video. We're going to solve 3 examples of the last 3 problems on your worksheet using the process of completing the square. So let's just go back through and review the process of completing the square. So when we start with x squared plus 2/9 x, what do we need to add to turn that into a perfect square? Well, we have to find our b value. In this case, our b value is 2/9. And from our discussion at the beginning of the last video, we know that if we take our b value and we multiply it by 1/2, and then we square it, we get the number we need to turn this into a perfect square. So we put in our 2/9 and we multiplied it by 1/2. Okay, and then when we reduced the 2 and the 2 and multiplied across, we got 1/9, and then we squared 1/9 to get 1/81. So we added 1/81 and put that in the blank, and then we went through the process of factoring. But at the end of the last video, I said you don't really need to factor because you already know what should go in the factor, okay? This is the part we got rid of at the end of the last video. We said that the 1/9, the number before we square, which is this 1/9, it is a positive 1/9, always shows up in the factor. The number before you square shows up in the factor. So in the previous example here, the number before we square it was a -1/7. So this became a -1/7 in the factor. And that is always true. So we're going to use that to our advantage to not have to actually think about our factoring. So in our previous examples, we always started off with a squared term and then our bx term here, right? Just the x term and the squared term. We didn't have this constant that's sitting over here, and then we were just adding something to turn it into a perfect square. But we didn't have this constant here. So what could we do to it? Well, we can move it to the other side. It doesn't have to be on this side with our squared term and our x term. So when we move it to the other side, our equation looks like this. But we know when we're solving equations that you can't just add something to one side. In order to keep it equivalent, you must add it to both sides, right? And we've done this since the beginning of the school year. So when we solve quadratic equations by completing the square, we're going to take our little constant here, this constant right here, we're moving it to the other side, and then we're going to set up and add some number to both sides that turns this quadratic into a perfect square. And remember, we call that completing the square. So we know to complete the square, to make that a perfect square, we have to take the number in front of our x term, our b value, multiply it by 1/2 and square it. So what's our b value in this case? Well, it's a +8. So I'm going to put that in for my b value. I'm going to take 1/2 of 8. 1/2 of 8 is 4. And then when I square it, I get 16. So I'm going to add 16 to both sides. And now when I factor, remember, when I factor, I can use the number that's inside before we square it. That should show up in my factor. So I know that x squared plus 8x plus 16 should factor into x plus, that's a +4. And that should equal, well, when I do this, what do I get here? -7 plus 16, that's a 9. So what are the factors of 16 that add to 8? 4 times 4 is 16, and 4 plus 4 is 8, so I know that works. So now this looks just like our homework that we did yesterday. We're going to use that square root property that we learned about yesterday to solve this equation. And remember, our square root property tells us that if we take the square root of both sides to solve, we must put this plus or minus in front. So when we take the square root of a perfect square, we just get what we were squaring to begin with. I know that the square root of 9 is 3 times 3. That's a nice group of 2 3s. So I'm going to get plus or minus 3. So I'm going to come up here to solve. Remember, we set up two equations. X plus 4 equals the positive solution, and x plus 4 equals the negative solution. So how do I solve for x? I subtract 4 from both sides. I'm going to do that in both of my equations. My 4's cancel out, and I get x equals -1, x equals -7, and I'm going to box my answers in. All right, so now let's do our next example. So we're going to do it the same way. We're going to get rid of our constant, our number 42 here. We got to move it to the other side. So I'm going to subtract it from both sides to get x squared plus 16x. This is where I add a blank, -42. And we remember we have to add the same thing to both sides to follow our property of equality. So now we're going to find our b value. We're going to multiply it by 1/2 and square it. Our b value is what is in front of our x. So we are going to set b equal to 16. And when I take 1/2 of 16, I get 8. And when I square 8, I get 64. I'm going to put 64 here on both of my lines. And so now when I factor, remember this is the number I should see in my factor. It's a +8. That's the number before it's squared. X plus 8 is a +8, right? 8 times 8 is 64. 8 plus 8 is 16. So 8 is going to be my factor. When I combine -42 and 64, I get 22. So now I'm going to use my square root property. I'm going to take the square root of both sides, and I can't forget the plus or minus. And I know that 22 is 2 times 11. I don't have a group of 2 of the same numbers, so that's not going to reduce. So I get x plus 8 equals plus or minus the square root of 22. And when I set up my two equations, I get x plus 8 equals the positive square root of 24, and x plus 8 equals the negative square root of 22, not 24. To solve and get x by itself, I need to subtract 8 from both sides. And remember, the square root of 22 and -8 are not like terms, so we can't really subtract them. We write it. We always put our number first. We had a -8 and a positive square root of 22. We have a -8 and a negative square root of 22. So we still end up with 2 solutions. All right, so now we're going to do our very last problem. All right, so this one's going to be a little bit more difficult because it is going to involve fractions. So again, I want to take my -9 and I want to move it to the other side. So since that's a -9, I'm going to add a 9 to both sides to get rid of it. So I have x squared plus 3x. That's going to equal 9. And remember, we're going to find something to add to both sides to make it a perfect square. And how do we do that? We find our b value, we multiply it by 1/2, and then we square it. So what are we adding to this side? We're adding a nice positive 3x. So positive 3, the number in front of the x, is our b value. We're going to multiply 3 times 1/2. And we're not turning this into a decimal, all right? We're going to leave it as a fraction. So when we multiply 3 times 1/2, we multiply across to get 3/2. And remember, when I square 3/2, I'm just multiplying it twice, and I'm multiplying across to get 9/4. So 9/4 is the number we're adding on both sides. All right, so again, I told you that we can use this number before we square it. That's going to show up in our factor. So how do you factor the left-hand side? Well, it's going to be x plus 3/2 squared, right? That number should show up here. It's a positive 3/2, so you see a plus 3/2 here. And that's going to equal, well, how do I add these two numbers? I have to find a common denominator. So that denominator is going to be 4. So I have to multiply that 9 times 4 to get 36. And 36 and 9 is 45 fourths. So now I'm going to use my square root property. I'm going to take the square root of x plus 3/2 squared. And remember, when we take the square root of fraction, we still have our plus or minus, but we're splitting our fraction up into the numerator and denominator. And I know that 45 is 5 times 9, and 9 is 3 times 3. I know that 4 is 2 times 2. So I have a nice group of two numbers in both my numerator and denominator. So now when I take the square root of a perfect square, I get x plus 3/2. That's going to equal plus or minus. I'm going to take that 3 out. 3 square root of 5 over. I'm going to take that 2 out. 2. So here's where I split it into two equations. X plus 3/2 equals positive 3 radical 5 over 2. X plus 3/2 equals negative 3 radical 5 over 2. So now in order to solve, I'm going to subtract 3/2 from both sides. And I know that 3/2 and negative 3 radical 5/2, that since they both don't have radical 5, they are not like terms. So I can't really add or subtract them. I get a negative 3/2 and a positive 3 radical 5/2. And then I get a negative 3/2 and a negative 3 radical 5/2. Okay, so that's how I would like you to do your homework.